You don't try and go into space and up to the moon and Mars and build space stations and so on so you can escape the Earth when you've messed it up. It is the opposite. The idea is that by going into space, building infrastructure, ultimately accessing resources in space, you save the Earth, because the Earth is the best place in the universe because we evolved on it and it's unique. I'm Brian Cox, and if you want my full title, I am Professor of Particle Physics at the University of Manchester and Royal Society Professor for Public Engagement in Science and Visiting Scholar at the Crick Institute in London, if you really want the full title. But I am here to answer questions from the Honesty Box. So the first question is, what is space? And that is a very good question. The 1 minute answer is, we don't know. So one of our theories is that space and time, for that matter. So I should say, back in 1905, Einstein realised that space and time are not separate, but they're woven together into something that's often called the fabric of the universe, or more technically, space-time. But we now suspect, or at least we have a theory, that space-time emerges from something deeper, which is just basically quantum entanglement. So we think that there is a description of our universe which is just bits of information, basically, or qubits to be more technical, quantum bits of information that are entangled together into some sort of network, so space and time don't exist in that network, and then space and time emerge from that deeper theory. This is cutting-edge physics, but it's one of the pictures that we have for what space and time might be. So there you go. What is space? It's also a thing that, you know, it's the distance between stuff that you throw about, whatever. Right. What is the best bit of evidence for alien life? We don't have any evidence for alien life, is the answer. So in the past, so we've landed missions on Mars, for example, the Viking missions in the 1970s, there was some suggestion that there might be some chemical reactions that looked a bit like life. And then it turned out that it probably wasn't, because it's very difficult to distinguish geology and chemistry from biology when you don't know what the kind of biology is that you're looking for. And so the answer is, we don't have any evidence of alien life, of life beyond Earth, but we're looking. So that's the answer. And then everyone will whinge about that. We'll go, what about that flying saucer that landed in Chicago or something? And I'll say, I don't believe it did. What's going to wipe out humans first? If I was to guess, I would say humans. And that's not supposed to be a joke. I think that the biggest threat to our civilization is us. So we have complete control over that, but it might not help us, which says something about our stupidity. Beyond that, threats from space. So if a comet came in from the outer solar system, as they do, and it happened to be aligned with Earth, it happened to hit Earth, then there's nothing we could do about it at the moment. Most of the asteroids, the big asteroids that cross the Earth's orbit, we've mapped, but there are a few maybe that we haven't. We're looking, so we're actively trying to do that. And if we see that one of those big asteroids might collide in the future, then we've got a bit of time, 10, 20 years, whatever it is, so we might be able to do something about it. We're going to have to leave the Earth at some point and spread out into the solar system and beyond. If we manage to do that, and we're at the point now where we're just about to start, I hope. So we're not far off being able to travel, build moon bases and then travel to Mars. We're quite a long way off going from Mars beyond the solar system maybe. We're a long way off doing that. But at some point, if we do that, then nothing's going to wipe us out. Is time travel possible? Great question. It's kind of obvious to say it's possible into the future, because of course that's what we're doing. We're moving into the future. It then gets interesting because you say, well, why do we have to go into the future? Why can't I stop going into the future? Well, you can vary the rate at which you go into the future relative to someone else. For example, if I was to get in a rocket now and accelerate off, even at 1g, right, just a sort of acceleration I could take, and head off and end up traveling relatively close to the speed of light, and let's say go to the Andromeda galaxy, and then, which is 2 million light years away from the perspective of the Earth, and then turn around and come back again. If I go close enough to the speed of light, I could arrange it so I would age, let's say, a year on the outward journey and a year on the inward journey. And you could do that calculation. But 4 million years would have passed on Earth. So I would come back on that journey 2 years older, but I'd arrive at the Earth 4 million years in the future. So that's special relativity. That's Einstein's theory published in 1905. It's not even the theory of gravity. So time travel is possible into the future, and it's inevitable that you travel into the future, and you can vary the rate you go into the future relative to someone else by the way that you travel around. In the past, Einstein's special theory of relativity from E equals mc squared, that thing in 1905, says no, you can't, because of the geometry of space and time themselves. His general theory of relativity, where space and time can be curved, that's his theory of gravity. The correct thing to say is that we can imagine distortion, geometries is the best way to say it. We can imagine geometries of space and time. Wormholes would be an example, where if you could go through them, you could travel into the past. However, we don't understand enough. So you can calculate these things, but whether or not they're possible to make is an open question. Most people think not. And the last thing I'll say, Stephen Hawking wrote a very famous paper called the chronology protection conjecture. And conjecture is important. So he conjectured that whatever the ultimate laws of quantum gravity are, they will be such that you can't build time machines that you can use to travel into the past. What's your star sign? I have no idea. Will we ever travel at the speed of light? No. So that's a simple answer. Anything that has mass cannot travel at the speed of light, but anything that is massless, that has no mass, has to travel at the speed of light. So photons, which are particles of light, for which, by the way, Einstein got the Nobel Prize, essentially, for something called the photoelectric effect back in 1905. So Einstein didn't get the Nobel Prize for relativity. He got it for this idea that you can think of light as a stream of particles hitting something and firing electrons out of it. So it's called the photoelectric effect. The way we understand physics at present, photons travel at the speed of light, not because they're light, but because they have no mass. So it should really be called the speed of massless particles. And that's built into Einstein's theory. It was subsequently realized, basically. So will we ever travel at the speed of light? No, unless you have no mass, in which case you have to. Prove to a flat earther that the world is round. I always say that I would hit them over the head with Newton's Principia. Because the implication, can you imagine if every time you get on a plane and fly somewhere, then the person who's in charge of the plane is part of a vast conspiracy that's trying to deceive you? Just imagine that. Right? How nervous would you be on the plane if the people that are flying it are actually just keeping you in the dark about the real nature of reality? How does that make you feel? You'd never get on a plane again. That would be great, because then when I go on holiday, I never bump into a flat earther because they don't travel. Favourite fact about the universe? This is an easy one, I think. It's the size of the universe. The bit we can see, which is what's called the observable universe, has about between 1 and 2 trillion galaxies in it, depending on how you know, little tiny galaxies and big galaxies. But it's let's say a trillion-ish, something like that. And that is only a small patch of the universe that exists, so we're sure of that. Whether the universe is infinite in all directions, we don't actually know, but as far as we can tell, it could be. So my favourite fact about the universe is that it might be infinitely big. Doesn't this all give you an existential crisis? Yes and no, because an existential crisis, it suggests, I suppose, that we question our own existence, doesn't it? That's what an existential crisis would be. Or at least you ask the question, what's the meaning of it all? Why are we here? I've got it written on my t-shirt, actually. Existence, what does it matter? And that's an Ian Curtis lyric. So I would say, yeah, listen to Joy Division. Is my answer. What would happen if Earth or a human fell into a black hole? It depends on the mass of the black hole, is the technical answer. So if it's a small black hole, by which I mean just, you know, a few times the mass of our sun, then you get ripped apart by the tidal gravitational forces before you actually fell in. So as you approach the event horizon of the black hole, it becomes very nasty. But for the very big black holes, so like the one we have a photograph of, we've got 2 photographs actually. One of the one in the centre of the Milky Way, and one in the centre of a galaxy called M87, which is a very big one. It's something like 6 billion times the mass of the sun. so a supermassive black hole in M87. It's 55 million light years away, that one. And if you fell towards that one, then as far as we know, you would fall across the horizon into the interior of the black hole, and you'd be unaffected. You wouldn't notice as you fell across the horizon. And then you'd have something like, I can't remember the exact number, but it's something like 30 hours-ish inside the black hole until you approach the singularity, which is in your future when you cross the horizon. So it's not something you can avoid. It's like trying to avoid tomorrow. You can't do that. So you go to this singularity, which is, in Einstein's theory, the end of time. And just before you get there, you get spaghettified, which means you get stretched in one direction and squashed in the other, and even your atoms get ripped apart, and then you go to the end of time. So that's not nice. However, if you put quantum mechanics in, which goes back to Stephen Hawking's work in the 1970s, then we can start debating about what the horizon is, and there are certain ideas that you might get when viewed from the outside. You might look to get, it might appear you get incinerated before you cross the horizon, and all your ashes come back out into space again. But from your perspective, it seems that you wouldn't get incinerated. From your perspective, you'd go inside, and then you get spaghettified. And then the question is, do you get vaporized or spaghettified? And the answer might be both, which is called black hole complementarity, which is all very complicated. So it's one of those things. Again, ultimately, the answer to what would happen if Earth or a human fell into a black hole is, for a big black hole, we don't really know. But for a small black hole, you would get ripped to bits before you fell across the horizon. Milky Way, Mars bar, or galaxy? It depends. I like them all. I like Mars bars when they've been in the fridge. I don't think Milky Ways work in the fridge. And galaxies work both in and out of the fridge.
Very diplomatic answer.
Is the multiverse real? This is not, how am I supposed to answer? I've got all these right. And every one of these questions, is the multiverse real? The answer is, it's very real as a possibility. For example, there's something called the inflationary multiverse. So one of our best theories of how our universe got to be the way that it is that before the Big Bang, then space and time still existed, and space was stretching very fast. It's a theory called inflation. And then that period of time draws to a close, so that the expansion rate, this incredibly fast expansion rate, slows down, and kind of the energy driving it collapses, changes form or state, and that's what we call the Big Bang. So the Big Bang is the end of inflation. Extensions of that, called eternal inflation, say or suggest that maybe that collapse, the end of inflation, maybe it doesn't all stop at once. So you're to picture patches of this rapidly expanding space that are sort of collapsing and making big bangs, which make universes. And so the process is called eternal inflation, because for all we know, it could have been going on forever in a sense, and would be going on now if that was correct. So we would just be a bubble in this sea, an infinite sea of universes, of which we're a single bubble, and that's called the inflationary multiverse. Quantum mechanics does appear to suggest that really there are an infinite number of universes. So every possibility for every interaction that happens has a probability of it. It's like rolling a dice, and you could say, well, I roll a dice and it comes up a 3, but it could also be a 2 or a 4. And basically, the many worlds interpretation of quantum mechanics is that there's a universe in which every dice roll happens. So that you get an infinite number of copies of you, for example, in this inflationary multiverse. Not the inflationary, the many worlds interpretation of quantum mechanics.
Is that the one that the Marvel multiverse would fit into? That second one, or is that...
Yeah, so I think, although there are issues with the Marvel multiverse, in technical issues, the thing is that these universes very rapidly, unless it's something like a quantum computer or something, they're very rapidly what's called decohere, so they become separated from each other. So whether you could travel between these different branches of reality is you know. So is that another controversial thing to say? Have I just upset the Marvel fans now? I don't know whether I've done that. Why is time different on different planets, like in Interstellar? So that's an easy question to answer. It's Einstein's theory of general relativity. As you come closer to a planet, then your time, so let's say you have a watch and you look at the watch, then you'll see the watch tick at the normal rate, 1 second per second, and you won't see anything unusual. But from the perspective of someone far away, that watch will be ticking more slowly than their watch. And it's really to do with the distortion of space and time in the vicinity of the planet. So the general rule is if you go to something that's very massive, so you approach a very massive planet or even a black hole, then as you go there, from the point of view of someone far away, they will see your time tick more slowly. So that's I was going to say basic general relativity. Should we leave it at that? Everybody should know a bit of general relativity. Explain Schrodinger's cat with the honesty box. So the idea with Schrodinger's cat is if you have this...
I have a cat here for you, by the way.
There's a cat. Right? So I get this cat and I put it in a box, and I have a radioactive nucleus in the box, and if it decays, the nice way to say it is it releases a sleeping potion, but in its original form it releases poison. And so if it decays, it releases some poison which kills the cat or puts it to sleep, and it could wake up again at some point depending on how sensitive you are. So it's either dead or it's not, depending on whether this thing decays or not. There's a probabilistic prediction for whether this thing is decayed or not. In just pure quantum mechanics, the nucleus is what's called in a linear superposition of states. So it's sort of some probability of being decayed plus some probability of being not decayed, and that's how you describe the nucleus. So that would suggest that's how you describe the cat. So the question is the correct description of this cat both alive and dead with some different probabilities that can change over time? But is that the correct description? And then you open it, of course, you see that it's one or the other. And so the question is that nonsense? Or the modern interpretation, especially the many worlds interpretation, would be that there's a universe where this thing is decayed and the cat's in, and I open this up and I see that it's alive or dead. So there's a universe in which I see it alive and a universe in which I see it dead. And the whole thing is just a big ensemble of probabilities called a wave function. So it was initially a kind of thing to say, well, this is a bit weird. It's got weird implications, quantum mechanics. And ultimately, it does have weird implications. And so that's it. So let's say it's the sleeping version, shall we, just to be all right. So that's Schrodinger's cat. What's your IQ? Don't know. But I saw somewhere some really ridiculous report that I'm happy to accept. And it was I think it was in a newspaper somewhere. And it said that my IQ was like one of the highest ever measured. It's never been measured. So I've no idea how high my IQ is. Should we try to save the Earth instead of trying to get off it? They're linked. It's a very serious question, this. It's really important to say that nobody I've spoken to, and certainly my opinion, is that you don't try and go into space and up to the moon and Mars and build space stations and so on so you can escape the Earth when you've messed it up. It is the opposite. The idea is that by going into space, building infrastructure, ultimately accessing resources in space, and all the good things you can do in space, drug development, developing semiconductors, all sorts of industries that we can imagine in Earth orbit, you save the Earth because the Earth is the best place in the universe because we evolved on it and it's unique. So the idea of going into space is not to mess the Earth up and then escape it. It is exactly the opposite. I was involved in a discussion yesterday, actually. It was really interesting. And one of the experts in the space economy said to me that really we shouldn't think of the space economy as space. We should think of it as the economy. And so, because it's not far, right? It's just 100 miles up there. So it's about we're in London now, so it's about the distance from London to Birmingham. If you go from London to Birmingham, but you go that way, you end up somewhere where you can do stuff that is useful, and it can produce economic growth. It can produce things like interesting drugs, for example, medicines and things which are not easy to build on Earth and so on. So you should think of space now not as a separate thing, but as a place where there's an opportunity to do stuff that benefits us all here on Earth, and that's the challenge. Does the Big Bang disprove the existence of God? No. I mean, I don't know why. It's kind of the opposite, actually, isn't it, in some sense? Because very quickly, historically, Georges Lemaitre, who's often described as the father of the Big Bang, was a priest as well as a mathematician. And he was delighted that Einstein's theory certainly appears to suggest that there could have been a beginning. Einstein didn't like that. He wanted the universe to be eternal. But Einstein's theory strongly suggestive of a beginning or an end. And Lemaitre, as a priest, was happier with that, because if you think about what a beginning is, you could call it in that language a moment of creation. So actually, historically, Lemaitre was more predisposed to accept that the universe might have a beginning because he saw that as a more of a suggestion that there could be a God, because then you have a thing as a creator. So, it's kind of historically interesting. Rank the planets from best to worst. I'm going to piss everybody off and say Pluto's the best, and that's going to really annoy everybody because it got demoted. So we'll have Pluto as the best one, because then we can have an argument about whether it's a planet or not. After that, then the Earth, surely, it's kind of an obvious thing to say, but obviously the Earth is the best because it's the place that we evolved on. It's the only place we know, not only in the solar system, but in the entire universe, for sure, that life exists. So it's clearly the best planet. Beyond that, if we're going to live anywhere else in the solar system on a planet, then it has to be Mars, because we can't live on Mercury because it's too hot or too cold. It's actually a strange place because it rotates very slowly around the sun. So anyway, it's not very nice, and it's small and hot and cold at the same time, depending on where you are. Venus is extremely hot enough to melt lead on the surface, sulfuric acid rain, 90 atmospheres pressure on the surface, so we're not living there. And all the others are made of gas, so we're not living on them either. So I'll go Pluto to annoy everybody, then Earth, Mars. And then it's interesting, so we have 2 missions at the moment on the way to Jupiter's moons, well, in particular Europa, which is a potential habitat for life. So I'd probably go Jupiter then because of its moons, but Saturn's moons are also interesting, particularly Titan, which is a planetary-sized moon, and Enceladus, which is a moon with liquid water below the surface as well. So I go for those. But if you ask me where would I send a space mission, where would be my number 1 choice, then I would say probably Neptune, because Neptune has a wonderful moon. Actually, that's a photo of it, actually. So that's Neptune, and Triton, as taken by Voyager 2, which took this image when it's the only spacecraft ever to have gone out here. So I would go for Neptune. Uranus, Neptune, I would send missions to, because we've only had 1 mission to them. So there you go. But let's just be really annoying and say Pluto.
Love that for Pluto. It's getting its moment.
Right. Would an asteroid destroy Earth? It wouldn't destroy the Earth, but it might make it extremely difficult for big things like us to live on the Earth. So an obvious example is for impacts from space, asteroids or comets. They're pretty much as destructive as each other. And the dinosaurs, the big dinosaurs, were wiped out by such an impact. There's an estimate, actually, that kind of scale of impact that civilization destroying or really affects life on Earth, some of the estimates are one in 100 million years or so, just as a broad estimate, knowing what we know. And it's worth noting that the asteroid that took the dinosaurs out was about, 60-odd million years ago. So, if you didn't understand statistics, you'd say it's time for another one.
Do we have systems in place to prevent that yet? Or
We do. So we have mapping projects. So we think we've mapped all or nearly all of the big asteroids that cross the Earth's orbit. And we monitor them, and we have what's called a keyhole system, which means that because their orbits can change through gravitational interactions with each other or with nudges from Jupiter's gravitational field and things like that, so they can change orbits, these things. And so we have a thing called a keyhole system, which if they go through this point in space, then we get more worried about it when it comes around again, and then we start tracking them more accurately. And we have had a couple of missions now to go land on asteroids, take samples from asteroids. We had an impact mission, which impacted an asteroid. So we are trying or beginning to develop the capability to move one if we need to move it. The problem is comets. Comets are nasty because they're big, and they often come in. We don't know they're there, basically. We only see them when they're on the way in. And so if a comet came, and for example, there was a comet called Shoemaker-Levy 9, which hit Jupiter a few decades ago. I can't remember the exact date. But that thing hit Jupiter, and the marks it left in the clouds of Jupiter were larger than the Earth. So you get a sense that these things are nasty things. So we don't want one of those coming, because there's nothing we could do, basically. I don't know why I'm laughing. Please explain dark matter like I'm a moron. In brackets, I am. It's really easy to explain, actually. Dark matter, when we look out into the universe, we see lots of things. For example, the speed that galaxies rotate, or the way that galaxies interact together, or actually the oldest light in the universe called the cosmic microwave background and patterns in it, which are suggestive of there being some kind of particle. So that's like this stuff, like electrons and things, but some kind of particle that's quite heavy and does not interact with light. So that's why it's called dark matter. You can't see it because it doesn't interact with photons, but it dominates the universe, 5 times as much of it as there is of this stuff, out of which everything we can see is made. So that's what dark matter, the best theory for it. We see it by its gravitational interaction. However, it's not shown, it's not proven that's the case because we haven't detected the particle. And there are experiments everywhere in underground labs and so on, at Large Hadron Collider at CERN, where we're looking for these things, but we haven't seen them. And so that leaves open the possibility that there's something else going on that we don't understand. What is déjà vu? I've been asked that before. Déjà vu, by the way, I think it's a property of the way that it's not a real physical property of the universe. It's the way that we perceive the world. But anyway, how does it feel being mixed up with Brian Cox, the actor? It's great fun, and I know him a bit, and we always laugh about it. One of the things that does happen to both of us, and it's happened to both of us, is we've got in a car, for example, in a taxi or whatever it is, and so it's been booked. And someone goes, "Oh, brilliant, it's the actor. I don't like astronomy, but I really like Succession. I'm so pleased it's you." Or they'll say to me, "Oh, I'm so glad it isn't. I wanted to talk about astronomy and whatever, alien life." And I was thinking, oh, it might be that other guy who does the thing, X-Men or whatever. Why isn't Pluto a planet? The reason is that since Pluto was discovered, we discovered a lot of objects that are very similar size, in similar orbits or in that region of the solar system. So it is true that there's no reason to distinguish Pluto from a load of other stuff that's out there. And so you have to say, well, what do we mean by, are we going to accept that there are 100 planets? Or do we find a different definition of a planet? Is it what we really mean, big things like Neptune and Earth and Jupiter? And do we really mean these little things, which are much smaller than our moon in many cases? So you could say that Pluto, it's a historical accident. It was the first one of these things beyond the orbit of Neptune, although Pluto does come in actually sometimes inside the orbit with these really strange orbits in the far reaches of the solar system. Just because it was the first one to be discovered, we call it a planet, and then we discover a load more. So that was why, basically. But I think that the history is important, and the thing is that it was demoted from its status as a planet before the New Horizons spacecraft, which was sent to explore it, arrived. So New Horizons was in transit. When it got there, I think if we'd just seen this lump of rock, I suspect you've gone, okay, it doesn't matter. But we found this world that is fascinating, and it's geologically active. It's got glaciers of nitrogen ice and mountains of frozen water. And it's geologically active, by which I mean there are parts of the surface, the famous heart on the surface that was seen, which is not, it's not got craters on it. And if you see anything that doesn't have craters in the solar system, it's new, because things are hitting things all the time. So it's this remarkable world. There's even suggestions it could have liquid water in regions below the surface, which could be a habitat for life. So it turned out to be a fascinating world. And so my view, although I've got loads of astronomy colleagues who would strongly disagree, my view is that the history sort of matters when combined with the fact that it's so interesting as a world that I would reinstate it as a planet. And you can then argue whether you should do that historically and so on. But yeah. So I'm going to go with Pluto as a planet, and this will be the thing that gets the most comments, probably.
We've got about 1 minute, so I don't know if you want to choose like 1 or 2 final...
I did, didn't I? Do you want to do it?
Yeah, go for it.
What existed before the Big Bang? Probably inflation. Or not probably, possibly inflation. So the universe was possibly still around before the Big Bang. What do you think about billionaires funding space travel? I think it's been a good thing, right? If you just purely for space travel, if you say what is revolutionising the space industry, access to space, it is SpaceX and following close behind Blue Origin. So I would say that those companies have opened up space. Question you're most sick of being asked, can things only get better? What are the northern lights? So it's the solar wind, which is particles that are ejected from the sun, stretching the Earth's magnetic field and then the Earth's magnetic field reconfigures and snaps back on the night side of the sun, and those charged particles are accelerated down towards the poles, and they excite molecules in the atmosphere, which means that they cause them to emit radiation, photons, and so the oxygen, the nitrogen, and so on, and you get different colours. Do you feel insignificant? Yes, but potentially extremely valuable as well, because this might be the only place in possibly in the observable universe, but maybe in the Milky Way galaxy, where there are things like us, collections of atoms that can think and ask these magnificent questions. Are you worried about the future of the world? Yes, definitely. And my worry, I'm also optimistic, because if we can transcend our differences, if we can work out how to organise ourselves on a planet and face global challenges together, rather than in an adversarial way, then the possibilities for us are endless and wonderful and magnificent. We're at the threshold now of spreading out from the Earth, becoming a multiplanetary and ultimately an interstellar civilization. So we know how to do it. So we're at the threshold of a remarkable transformation in our fortunes. But I'm worried that just because of our internal differences as people, and countries living on this one spacecraft, essentially, then we won't manage to get to that. It's within our grasp. So a magnificent future is within our grasp. And it worries me that we might not be able to grasp it. And do we have too many scientists? Do we have too many satellites? There you go. It's a Freudian slip, isn't it? Do we have too many satellites and space trash? Yes. And one of the great challenges we're facing at the moment is to develop a regulatory structure that allows us to, for example, remove it. So if it's useless, then who owns it? Who's responsible for it? Can someone who doesn't own it go and remove it anyway because it's useless? And so that's one of the biggest challenges with industrializing near-Earth space.
Completed the box. Round of applause. That was amazing, Brian. Thank you so much.
So farts in space, basically in weightlessness, hot air doesn't rise. So the good thing is you probably won't smell your own fart, because by the time you've done it, it's already been taken away by the air conditioning system.